The last presentation is about the damage of ductile cast iron. The first presentation I showed you what it happens when ductile cast iron is automatically galvanized. In this case, we use the same ductile cast iron. So it's not the same. It's a fully pearlitic ductile cast iron. The first one is pearlitic ductile cast iron, but it's focused on the damage of nodular graphite. Why ductile cast iron? Because it's a cheaper material, and the mechanical behavior of this kind of material is quite similar to behavior of conventional steels. But the cost, the production cost of ductile cast iron is lower, because we need also properties as oxidation of carbon after cast from the furnace. And we can have the formation of the nodules of graphite just by addition of cerium or magnesium, as in the last processes. It is very cheaper. So this is the behavior in terms of tensile performances of different ductile cast iron. You can see the ductile cast iron characterized by fully ferritic matrix, ferriti-pearlitic, and fully pearlitic behavior. This is the behavior of conventional gray iron. We can see the values of stress and the elongation are much more better. So this is the reason because a lot of components now are made on ductile cast iron. You can see the belts, boxes, bearing, hubs, wheels, gears, and so on. It is important in this way to have a model in order to predict the mechanical behavior of these components. And in the literature we can see a lot of models mainly based on specific basic which the graphite nodules are modelized as a void. We think this is not true because the presence of carbon inside the matrix is a presence of material. It is not a void. And the performance of graphite are not zero as a void, but mainly in terms of compression are not negligible. For this reason, we observed in review works the different way of damage of graphite. In this case, we observed typical, most important damage observed and described in the literature. It is named as the bonding. It consists in a separation of boundary of graphite to the matrix. It means that there is no action of graphite on the matrix in this way. But in other works, we observe that this is not the main damage mechanism. There are a lot of mechanisms. This is one of these. In this case, we can see the separation inside of nodules, separation of core to the external outer rings. We named this kind of damage as a nodule-like. We observed this mechanism in many of our experiments. Another kind of damage is this. we have a collapse of nodules, and this crack starts from the center of the nodules and propagate through the nodules, giving a separation of these nodules. We think this start from the center because it's a critical point, because it's the nucleation of the nodules obtained, for example, in corresponding to a presence of metallic inclusion and so on. So we used a fully pearlitic ductile cast irons in order to investigate the properties, local properties of the graphite, because we think that the behavior, mechanical behavior of the graphite is not the same from the core to the outer zone, observing the different damages. In the experimental procedure, it is important to prepare the surface, because the surface which we are testing can be taken in this way, where the cutting surface done is across the center of the nodules. In this way, we can see the properties of the core nodule, but just also of the outer surface. The second one is almost off the center, and the third, we can see that the plane observed is perfect on the center of the nodules. This is the correct position in order to evaluate the difference of mechanical properties of the graphite, but it is not so easy to achieve this situation. What we have to do? But we have to observe just the nodules characterized by bigger diameter, because in this way we have a case like this one. In this case, we used a traditional nano-indenter test by using an Berkovich indenter. This is the condition used in our test, loading type linear. This is the loading rate, maximum load. The unloading rate is the compressional. This is a compressional parameter. And we used a sort of matrix of indentation. The distance between the indentation is about 20 micrometers. In order to take all the characteristics in this region. This is another picture where we can see the position of different indentation. The projector is not so good, but inside of this graphite we have the shape due to the indentation process. This is the first results. We can see this picture is the calculated young modulus obtained by the traditional Olivier Bard methods, assuming Poisson ratio about 0.3. And here we have the evaluation of nano hardness. We can see in the center of the nodules we have a low values of micro hardness, and in the outer zone we have a sort of ring characterized by the same nano hardness. This is probably due to a cutting surface of our nodules like this. It's not completely in the center of this, near to the center of the nodules, but it's not in the center. This is another nodule. In this way, the center indented is much more bigger than the first nodule. And we think in this case we are in the correct position of cutting nodule. In this way we can see the diameter of core and the diameter of the outer zone. Considering the equilibrium diagram of this ductile cast iron, we can see we put here some consideration about the solidification of the alloy, and we can see the diameter of the nodules, the core of nodules, which it happens in the melt condition, liquid condition, is about 38% of the entire diameter of the nodules. It is correspond to the second nodules measurement, and we have another consideration about the diameter of the outer zone, which is realized in the euthetic solidification of the alloy. In this case, the diameter of the nodules is about 90% of the entire nodules, and so on. This variation of diameter corresponds to our measurement, just in terms of nano hardness in our regulation. So, in conclusion, we think that the behavior of graphite of nodules is not the same if compared to the center of the outer zone of the nodules. This is due to the formation of this region of nodules, because the diffusion at the solid state in the austenitic phase after the solidification at the euthetic temperature is a mechanism much more different to the euthetic phenomenon, and it is different to the mechanism that involve the formation of nodule in liquid phase. So, thank you for your attention.